In this video, we're going to graph some quadratic functions that are in vertex form. So for each of the quadratic equations, we need to find the following and then graph. So we have 9 minus x plus 2 squared. I can tell that this is in vertex form because it has those sets of parentheses. And so to write it in actually this form where I have my squared portion first and then my k at the end, I'm just going to move this 9 to the back. So this is the same as f of x equals negative x plus 2 squared plus 9. I'm just going to rewrite that so that it matches my form here. So it doesn't ask anything about whether this goes up or down, but let's talk about that real quick. It's good to kind of look at this and determine if it opens up or down so you can check as you're graphing. Because my a right here, in this case, my a is -1. Because it is less than 0 or negative, this negative out front tells me that this parabola is going to open down. So let's keep that in mind. Okay, the first thing I need to do is find my vertex. Well, luckily here, this is in vertex form. My vertex is in the form of HK. My H is with my X. And so again, notice here that this is negative H, but here it's positive H. You need to change that sign. So because this is positive 2, this is negative 2. And then my K is back here. And you have K and K. These are both positive, so we'll keep that sign. So this is 9. Okay, so that's my vertex. Then I need to find the axis of symmetry. Your axis of symmetry is just x equals h. In this case, my h is -2, so we've got h equals -2. So I'm going to go ahead and plot those on my graph. We've got -2, 9. Because I know this is going down, that's okay to have a vertex that high. So this should kind of droop down. And then I'm going to put my axis of symmetry at -2. Notice that it goes right through that vertex. So all I'm going to do to represent that axis of symmetry is to do a dashed line. This isn't really part of the graph, so that's why it is a dashed line. But whatever happens to this side over here should mirror it. It should look the exact same. So now part I guess they're all I's, 3I, we need to find the x-intercept. So to find the x-intercept, we're going to let y equal 0 and then solve for x. Well, y is the same thing as f of x. So in this one here, I'm going to do f of x, or 0, equals, and then my equation. So I rewrote this, but instead of f of x, I have 0 equals. And now we're going to solve by factoring square root property or method or the quadratic formula. Because I have this squared portion here, the easiest thing to do is the square root method, which tells me to get the square root portion by itself. So to do that, I need to move my 9 over, and I'm going to do that by subtracting. So I get -9 equals negative x plus 2 squared. I still don't technically have the squared portion isolated because I have a negative right here. So I'm going to get rid of it by dividing it over. My negatives go away. Negative 9 divided by negative 1 is 9. And my negative went away. So now I have my squared portion isolated. So the opposite of squaring is to take the square root. So my square root and square cancel, and I am left with x plus 2. Be careful over here. The square root of 9 is plus or minus 3, not 3. You only put 3, you forget you're going to lose one of your solutions. Keep going and solve for x. And we will do that by subtracting over our 2. You can write plus or minus 3, minus 2, but I like that the other way. So I'm going to say x equals negative 2 plus or minus 3. So now I can go and get my 2 solutions. I've got negative 2 plus 3, which is going to give me 1. And I have negative 2 minus 3, which is going to give me negative 5. I need to write these as ordered pairs. So I found my x's. And what did we put in for y? We put in 0. So this is 1, 0, and negative 5, 0 for my y-intercepts. Sorry, for my x-intercepts. So let's plot that. I've got 1, 0, and negative 5, 0. You can use your axis of symmetry to check. They need to be the same distance on both sides. So from my axis of symmetry, this is 1, 2, 3 units over, and this one is 1, 2, 3 units over. So we're good. Part 4 wants me to find the y-intercept. To find the y-intercept, we're going to let x equal 0, and now solve for y, or again, f of x. There will be one, so I need to make sure I get one solution here. So I'm going to take my equation, I'm going to replace this with y, and I'm going to put 0 in for my x. So I have y equals negative 0 plus 2 squared plus 9. And now I'm going to simplify. We get 2 here. 2 squared is 4. Keep that negative, just bring it down. So we get negative 4. And so y here equals 5. So if I write that as an ordered pair, I replaced x with 0, and my y is 5. So I'm going to go ahead and plot that as well. And so I have these 4 points. I'm going to go ahead and get a 5th one. I typically like 5. Notice that this is 1, 2 units over from my axis of symmetry. So I'm going to go 1, 2 units over in the other direction. And so here's my parabola. And so when you graph this, try your best to not make this pointed. It's not a V, it is a U shape. Okay, so there's my parabola. And so now part 5 and 6 wants the domain and the range. So we haven't done this in a while. So do your domain, you're going from left to right. When you go to the left, or when you start left and you go right, you get an arrow first and then an arrow second. For our parabolas that we are doing in this lesson, the domain is always going to be negative infinity to infinity because we're dealing with functions here. And then I need my range. So domain, we go left to right. Range, we're going to go bottom to top. So I'm going to go bottom. I hit arrows first. So I've got negative infinity. And then what's the highest thing I touch right here is 9. Remember, it's not where it's crossing the y-axis because you still have a y value at 6, at 7, at 8, at 9, but you don't here at 10. So this is going to end at 9 and it is included. So this is negative infinity to 9. And I messed up. I said 9's included. To include it, you need brackets. Okay, let's try another example. Okay, we're finding the same 6 things. And I can again tell that this is vertex form because I see that grouping of parentheses here, right here. So before I even start, it doesn't ask for it, but is this parabola going to open up? Oops, that's not the right one. Is this going to open up or open down? Well, my A right here is 1, specifically a positive 1. So because A is greater than 0, let's just kind of make a note that this parabola is going to open up. All right, so first part is to find the vertex. Here is my H, and here is my K. You got minus H here, which becomes a plus H here. So this minus 3 becomes a positive 3. You're always switching that sign. Right? Just like on my first one, this was a plus 2, but my vertex is a negative. You switch what's inside those parentheses, and then your K is positive, positive. So you're going to keep the sign here. So this is 2. Okay, that's my vertex. Part 2 wants my axis of symmetry, and my axis of symmetry is just x equals h. It's x equals your x coordinate of your vertex. So this is x equals 3. So let's put those on our graph. I've got 3, 2. And my axis of symmetry goes right through that at x equals 3. Again, that's dotted because it's not technically part of the graph. It's an imaginary line where whatever happens to this side, which we know is going up, so whatever happens to this side, we know it's going to be the same to this side over here. Part 3 wants an x-intercept. Now, you kind of just saw what I did. You should know the answer to this. If I know my vertex is here and that this is going to be going up, my shape is going to be somewhat right here. This does mean I'm going to have no x-intercept. Now, if you don't recognize that your vertex is here and it's going up, let's see what that looks like mathematically. So, here we are. To find the x-intercept, we're going to let y or f of x equals 0 and solve for x. So my equation here is going to be 0 equals, because that's my y, x squared minus 3, or x minus 3 squared plus 2. We're going to solve this for x, and we're going to solve either by factoring, square root property or method, or the quadratic formula. When this is in vertex form, you always want to use square root. Okay, so we will use square root method again because we are in vertex form. So vertex form says to get this squared portion by itself. So we need to do that by moving the 2 over. Okay, now that I got my squared term by itself, the opposite of squaring is to take the square root. Notice here, I've got the square root of -2. And I said before, if you get the square root of a negative number, that's your imaginary. That means we have no x-intercept. So, because of this negative here, we have no x-intercepts. Okay, we need to find the y-intercept. We find the y-intercept by doing the opposite. We're going to let x equal 0 and solve for y or f of x. So I'm going to replace f of x with y. I've got y equals, replace x with 0. So 0 minus 3 squared plus 2. So solve for y. 0 minus 3 is -3. -3 squared is 9. Plus 2 is 11. So as an ordered pair, we have 0 for x, 11 for y, 0, 11. Okay. So it's going to be a little bit off your graph. We got 0, 11 right here. And this is 1, 2, 3 units away. So I'm going to go 1, 2, 3 units away from that axis of symmetry. So I can see the shape of my graph right here. This is enough to draw this. Now, I personally like 5 points. So if I want another point and I don't have an x-intercept, just pick a point. I know my vertex is here. So if I go 1 over and pick 4, plug in 4 to your equation. I'm going to go f of 4, which you can't see what I'm doing, which means replace your x with 4. So I have 4 minus 3 squared plus 2. I just replaced this x with 4, and I picked 4 because I know it's 1 over on that vertex. So I get 1 squared plus 2, which is 1 plus 2. So f of 4 equals 3. So I have another ordered pair at 4, 3, which is right here. And it's 1 unit away from my axis of symmetry. So I'm going to go 1 unit over on my axis of symmetry here. This just simply gives me a better idea of the shape of this graph when I am sketching it. But it is not necessary. And again, make sure that's rounded. You don't want that to be V'd. Okay, so now part 5, I need the domain. And then part 6 will need the range. So domain is left to right. So left to right, we hit arrows first, we hit arrows last. That means this domain here is -infinity to infinity, which is the same as saying all real numbers. Your domain for all of our parabolas today will be all real numbers. Now your range is going to change. Range, you're going to go from the bottom to the top. So what is the least y value that we get? Right here at 2. And then the last thing I hit are arrows. So my range is 2 to infinity. I went bottom to top.